Hello everyone, in continuation to my lectures on enzymology, today we are going to discuss about the enzyme inhibition. So what are inhibitors? Inhibitors are the molecules that resembles the substrate or the product and bind to the active site, thus they interfere with the catalysis, slowing or halting the enzymatic reactions. Many drugs are reversible enzyme inhibitors. They have their physiological effect by decreasing the activity of a specific enzyme. For example, aspirin. The acetyl salicylate inhibits the enzyme that catalyzes the first step in the synthesis of prostaglandins. These are the compounds that involved in many processes, including some that produce pain. So, aspirin is used as a painkiller. The concentration of the inhibitor needed to inhibit the enzyme depends on how tightly the inhibitor binds to the enzyme. Inhibition constant Ki is used to describe how tightly an inhibitor binds to an enzyme. Now, the types of inhibitors. There are two broad classes of enzyme inhibitors. The first is the irreversible and the second is the reversible. Coming to the first, that is irreversible inhibitors. Irreversible inhibitors are those that bind covalently with the enzyme or destroy a functional group on an enzyme that is essential for enzyme's activity, or that form particularly stable non-covalent association. The formation of a covalent link between an irreversible inhibitor and an enzyme is common. For example, the reaction of the chymotrypsin with the diisopropyl fluorophosphate DIFP irreversibly inhibits enzyme by binding with the serine 195 in the active site of the chymotrypsin. Diisopropyl fluorophosphate is a nerve gas that developed by the Germans during the Second World War, binds with the enzymes like the serine proteases, acetylcholinesterase, etc. This is the structure of the diisopropyl fluorophosphate, and this is the enzyme with the serine in its active site. When both of these form a covalent bond, then the complex is a stable complex which can permanently inhibit the enzyme activity. Now, the reversible inhibitors. This type of inhibition involves the equilibrium between the enzyme and the inhibitor equilibrium constant, that is Ki, being the measure of the affinity of the inhibitor for the enzyme. The inhibitors bind non-covalently with the enzyme, and the inhibition can be reversed if the inhibitor is removed. And this reversible inhibition is of three types. The first is the competitive, the second is the non-competitive, and the third is the uncompetitive type of reversible inhibition. Coming to the first, that is the competitive inhibition. Competitive inhibitors bind only to the free enzyme and to the same site as the substrate. Competitive inhibitors are the molecules that usually look like the substrate but cannot undergo the reaction. At an infinite concentration of the substrate, competitive inhibitor cannot bind to the enzyme, since substrate concentration is high enough that there is virtually no free enzyme present. If we talk about the reaction, then the enzyme will add on with the substrate, will form the enzyme substrate complex, and then further enzyme is separated and the product will formed. But the inhibitor I, which is closely resemble to the real substrate S, is regarded as a substrate analog. The inhibitor competes with the substrate. This inhibitor I is compete with the substrate S and binds at the active site and forming the enzyme and inhibitor complex instead of forming the enzyme substrate complex. As we have already discussed about the factors affecting the enzyme activity, in which one factor is the concentration of the substrate, And we have also discussed about the rectangular hyperbola we get when we plot the graph between the substrate concentration and the enzyme velocity. So, this is the graph, and with this graph we can observe that under the competitive inhibition the V maximum remains unchanged, but the Km increases. V maximum is the maximum velocity, so we cannot go above the maximum velocity. So, this V max in any type of inhibition either remains unchanged or it gets lowered. Km is the Michaelis-Menten constant, and it denotes the strength of the association between the enzyme and the substrate. And what is the relation? If there is increase in the Michaelis-Menten value, then there is decrease in the affinity, and the vice versa. So, if we can plot the graph, between the concentration of the substrate on the x-axis and the velocity at the y-axis, then we can get a rectangular hyperbola. This pink color will show the rectangular hyperbola with no inhibitor. But if we plot the graph with the competitive inhibitor, then this blue color shows the graph with the inhibitor, with the competitive inhibitor. In the competitive inhibition, V maximum remains unchanged and the Km increases with the inhibitor. Here we are observing that the V maximum value with no inhibitor and the V maximum value with the competitive inhibitor is same. So, the V maximum value remains unchanged, but the Km value increases with the inhibitor. Secondly, if we draw the Lineweaver-Burke double reciprocal plot also, in which we can get a straight line, curve between the reciprocal of the substrate and the reciprocal of the velocity. This is the reciprocal of the substrate on the x-axis, and this is the reciprocal of velocity on the y-axis, and this is the straight line curve without the substrate, and this is the straight line curve with the without the inhibitor, and this is the straight line curve with the inhibitor. And this curve also denotes that V maximum remains the same, but the Km value decreases. The Km value increases with the inhibitor. The example is the succinate dehydrogenase. The succinate dehydrogenase is an example of a competitive inhibition with the succinic acid as its substrate. Malonic acid, glutaric acid, oxalic acid, etc. have a similar structure to the succinic acid. So, this is the structure for the succinate and the malonate. Now, coming to the non-competitive inhibition. Compounds that irreversibly bind with either the enzyme or the enzyme substrate complex are designed as non-competitive inhibitors, and this reaction shows the binding. The inhibitors has no structural resemblance with the substrate, but when the inhibitor can bind to the enzyme will form the enzyme inhibitor complex, or the inhibitor can also bind to the enzyme substrate complex to form the enzyme substrate and inhibitor complex. So, finally, the enzyme is inhibited. The non-competitive inhibition therefore differs from the competitive inhibition in that the inhibitor can combine with the enzyme substrate complex and the substrate can combine with the enzyme and inhibitor complex to form in both the instances they will form the enzyme inhibitor and substrate complex. The inhibitors has no structural resemblance with the substrate, and here inhibitors bind at a site other than the active site, which change the conformation of the enzyme and hence impairs the enzyme function. For example, amino acid alanine non-competitively inhibits the enzyme pyruvate kinase. Alanine is one product of a series of enzyme catalyzed reaction in which the first step of which is catalyzed by the pyruvate kinase. Or we can talk about the heavy metals can also act as a non-competitive inhibitors like mercury or the lead, etc. can non-competitively bind with the enzyme. Now, the uncompetitive inhibition. If the inhibitor combines only with the enzyme substrate complex and not with the enzyme, then the inhibitor exerts its effect only at a high concentration of the substrate at which there is a lots of enzyme substrate complexes around. This means that the increasing substrate concentration doesn't prevent the binding of the inhibitor. Interestingly, Km value is consistently smaller than the Km value of the uninhibited reaction, which implies that the substrate is more effectively bound to the enzyme in the presence of inhibitor. The sequence of this type of reaction is that here the enzyme binds to the substrate and form the enzyme substrate complex, and the inhibitor binds to this enzyme substrate complex and form the enzyme substrate and inhibitor complex to inhibit the enzyme action in the uncompetitive inhibition. This type of inhibition is often observed for the enzymes that catalyze the reaction between two substrates. Often, an inhibitor that is competitive against one of the substrate is found to give uncompetitive inhibition when the other substrate is varied. The inhibitor does combine at active site but does not prevent binding of one of the substrates and vice versa. For example of uncompetitive inhibitor is inhibition of the placental alkaline phosphatase by phenylalanine. And in this type of inhibition, the V maximum as well as Km value both are decreased. Here you are observing that there is a lot of distance between the V maximum with no inhibitor and the V maximum with the inhibitor. So, there is the decrease in the V maximum and the decrease of the Km value also in the uncompetitive inhibition. In the Lin-Weaver-Burr plot also, and in this substrate and the velocity curve also. Now, coming to the enzyme inhibition mechanism, what is the difference? If we talk about the competitive inhibition, then the substrate and the inhibitor both can bind to the active site by competition, means they can compete for the active site binding. So, the substrate will also bind to the enzyme active site, or the inhibitor can also bind at the active site. Both of them can compete to bind at the active site. The inhibitor I binds to the free enzymes only in case of competitive inhibition, and competes with the substrate, and the increasing substrate concentration overcomes the inhibition by inhibitor. In case of non-competitive inhibition, there is an active site for the binding of the substrate, but there is also another site for the binding of the inhibitor. So, there are different sites for the binding of the substrate and the inhibitor. So, the inhibitor can bind directly to the enzyme to form the enzyme and inhibitor complex, or the inhibitor can bind to the enzyme and substrate complex to form the enzyme inhibitor and substrate complex in case of non-competitive inhibition. The inhibitor binds to the free enzyme or the enzyme substrate complex. Increasing the substrate concentration cannot overcome the inhibition in the case of non-competitive inhibition. If we talk about the uncompetitive inhibition, then what will happen? The substrate can bind to the active site of the enzyme. It will form the substrate enzyme complex, and then the inhibitor can bind to this enzyme substrate complex. Inhibitor can bind to the enzyme substrate complex to form the enzyme inhibitor and substrate complex. In this case, the inhibitor binds to the enzyme substrate complex only, and increasing substrate favors the inhibition by inhibitor. So this is the difference. For the competitive inhibition, the increasing substrate concentration overcomes the inhibition by inhibitor. In non-competitive inhibition, increasing substrate concentration cannot overcome the inhibition, and in case of uncompetitive inhibition, increasing substrate concentration favors the inhibition by inhibitor. So this is the mechanism of inhibition for the competitive, non-competitive and uncompetitive inhibition. So this is all about the enzyme inhibitors. If you like this video, please do subscribe my channel and share with your friend. Thank you for your time.